Hi there once again. This video, again, in talking about different forms of complex numbers. Converting forms, here we go. This one is going to go the other way, though. We're going to convert a rectangular number to a polar number. All right, so we're going from that's a plus bi form into r times cosine theta plus I sine theta. All righty, so we'll do just a couple of examples here, so this won't be too long. First example here is we're going to let our z be 1 plus I. That's a cute little complex number there, 1 plus I. And if we were to first examine where that point would lie in the complex plane, which is, by the way, a super important thing for you to do almost every time you do this, you've got to think about where that point is. It's very, very helpful. So we look at that xy plane there. It is 1 unit to the right and 1 unit up. It's right there in quadrant 1. And what we are looking for to convert it into polar form is the r and the theta for that number. Okay? So now that we are clear on the task, let's just go ahead and do it. If you recall, the r is just using the Pythagorean theorem there. Super easy with this one. It's the square root of a squared plus b squared. That's just 1 and 1, and yep, we're done with r. It's the square root of 2. Okay, good. See, this is pretty easy. Let's find theta now. Theta, as our kind of default rule for finding theta, is the inverse tangent of b over a. And let's go ahead and do that, but I bet you can look at that drawing over there and think right away what theta is. Just kind of say it silently to yourself as we work through this, and I bet you'll be right. So that's b over a. That's 1 over 1. Okay, so we're talking about the inverse tangent of 1, which is pi over 4. In quadrant 1, that is pi over 4. So that's hopefully what you said there. Well, we found r, we found theta. Ha! We're done. There it is, the polar form of that number. Look at all that stuff there. Just we went from cute little 1 plus I to this root 2 times cosine of pi over 4 plus I sine pi over 4. Pretty impressive, right? I want to just point out a couple of things about this number here. The number in front, that is what is called the modulus. It's a Latin word. It means something I don't know exactly. But that's what it's called. That's the r. It's the modulus of z. And the angle is called the argument of z. All right? So we have the modulus and the argument, the r value and the theta value for that polar form of that complex number. All righty, let's move on and try to do another one here. So this time, again, rectangular form to polar form, our number is going to be negative 6 root 3 plus 6 I. There we go. And if we think about where that number lies in the complex plane, negative 6 root 3 for a, meaning it's horizontally measured to the left of the origin, and positive 6 for I, so that's up 6, so it's in quadrant 2. Really important to recognize that and just kind of note where that point lies, in which quadrant especially. The reason is because we have to take that into consideration when we're finding theta, the angle or the argument for z. Okay, let's continue. We are again looking for r and theta, so let's find r. It's the square root of a squared plus b squared. You work those numbers out. Negative 6 times the square root of 3 squared, that actually equals 108. 6 squared is 36. You add those together, you get 144. So the square root of that is 12. R is 12. Okay? Not bad. So let's find theta now. Inverse tangent of b over a, in this case that's 6 over negative 6 root 3, and so the whole fraction is negative. That does kind of simplify down a little bit down to just the negative square root of 3 over 3. And in quadrant, the typical output for that statement right there, in inverse tangent of negative root 3 over 3, is negative pi over 6, which is over there in quadrant 4. Sort of like quadrant negative 1, but it's not in the quadrant 2. In fact, it's 180 degrees away. So if you add pi to this, in quadrant 2, that angle there would be 5 pi over 6. And we can get that just from kind of knowing the unit circle well enough, or by adding pi to what we got from the first place there. Okay? In any case, our angle is 5 pi over 6. So there's our number, that's our argument. We've got the modulus, we've got the argument. We can write the number now. Z is 12 times the cosine of 5 pi over 6 plus I times the sine of 5 pi over 6. There you go. That's another example there. So I hope you enjoyed that. Keep those rules in mind. The only tricky part about any of these things is finding theta. So you've got to make sure you know where the point is and in which quadrant it's lying, and that guides you to the correct angle. Okay, well, go do some math and be well. Bye-bye.